In this problem, we have four vectors u, v, and w, and the scalar a. Prove that a. U times v equals to v times u. b. U times av equals to a times u times v. c. U times v plus w equals to u times v plus u plus w. So, since these are vectors, we can first assign them a vector form. So we can let u equal to u1, u2, v equal to v1, v2, and w equals to w1, w2. So then, we have u times v equal to, for the properties of vectors, to multiply them, you have to multiply the top portion and then add it to the product of the bottom portion. So this will equal to u1 v1 plus u2 v2. v times u equals to u1, this equals to v1 u1 plus v2 u2. And this will equal to u1 v1 plus u2 v2 by a commutative property of multiplication. So u times v equals to v times u. For part B, we have u times av. This will equal to u1 u2 times av1 av2, because when you are multiplying by a scalar to a vector, you have to multiply the scalar to the top portion and bottom portion of the vector. So this will equal to, by a multiplication of vectors, u1 av1 plus u2 av2. And then this will equal to, you can factor out the a, u1 v1 plus u2 v2. Then for a times u times v, this will equal to a times, just multiply the vectors, which is u1 v1 plus u2 v2. So this will equal to u times av. For the last part, we have u times v plus w equals to u times v plus u times w. So we have u times v plus w equals to u1 u2, which is the vector form of u. Multiply this by v plus w. v plus w, when you're adding vectors, you add the top portion and bottom portions respectively. So this will become v1 plus w1 times v2 plus w2, which equals to u1 v1 plus w1 plus u2 v2 plus w2. Then for u times v plus u times w, this will equal to u1 v1, which is u times v equals to u1 v1 plus u2 v2. Add this to u times w, which is u1 w1 plus u2 w2. Then we can rearrange the terms. This will become u1 v1 plus w1 plus u2 v2 plus w2. So that is how you prove that these three are equal. And these are also known as the dot products of vectors.